Hey guys, Mr. Gran 6.1. In this video, we're going to be focused on interior angles of polygons. All right, so our interior sum theorem. So unlike exterior sums always add up to 360, but interior sums, we've got a little bit of formula because it's different for each polygon, and it depends on the number of sides. So your n value here, this is, remember, the number of sides, the number of angles. This is how you figure out what the interior sum is. So like if we think about a triangle, right, we know that the sum of all the angles in the triangle add up to 180. Well, that has three sides. 3 minus 2 times 180, that gives us that 180 for a triangle. If we look at a square, right, all of these are 90 degrees, so that adds up to 360. 90 times 4 is 360. Well, if I plug in my 4 sides minus 2, that's 2 times 180, which is also 360. And it works for all other polygons as well. Okay, so we want to know the sum of the interior angles of an octagon. Well, all we really need to do is know that for an octagon, the number of sides is 8. And then we can do 8 minus 2 times 180, and that is 6 times 180, and that is 60, and 48 is 108 with a 0 at the end, 1,080 degrees on the interior of an octagon. So all of these angles on the inside of our octagon, add all those together, and that is going to equal 1,080. All right, I'm not going to sketch this one. A 30gon, meaning a 30-sided shape. So it's starting to look darn near like a circle once we get up to that point. Well, mathematically, it's pretty easy, right? 30 minus 2 times 180, so that's 28 times 180, and that is 5,040 degrees. All right, so looking at this, solving for x. Well, I've got a pentagon, right? It's got 1, 2, 3, 4, 5 sides. And so what I really need to do is figure out how many degrees there are in a pentagon on the interior angles, and then I can kind of figure everything out from there. So n here is equal to 5 because it's a pentagon. So I'm going to start out doing 5 minus 2 times 180, which is 3 times 180, which is what? 540. So that's the total amount of, that's the total degrees on the inside of this, right? So that means that 540 is equal to, I've got x, I've got another x, and I've got 1, 2, 3 90-degree angles. So that's 90, 180, 270 is equal to 540, right? We can combine our like terms here. 2x plus 270 equals 540. And then now we can solve this. So we'll subtract 270 from both sides. And we get 2x is equal to 270. And then if we divide both sides by 2, each of those angles on the bottom, half of 270, is equal to 135 degrees. All right, now we get a little more complicated. This is a fun one. All right, we need to know how many sides we have, so we know what the sum of those interior angles is, what they all add up to. And how many sides do I have? 1, 2, 3, 4, 5. So it's another pentagon. We've got n equals 5, so we know that it's going to add up to 540. We just figured that out for the last one. So what I want to do is add everything together and set it equal to 540. So we've got a 3x plus 4, cross that one off, a 7x minus 3, cross that one off. A 6x plus 12, cross that one off. A 6x minus 3, cross that one off. And then don't forget about this 90-degree angle here, right? Not 60, 90. How is that for an equation? It's actually not that tough, right? We can do this. It's just, we just got to be careful and stay organized. Let's start by adding all of our like terms. So we've got 3, 7, 6, and 6 for the x's. So that's 10, 16, 22x. And then for our numbers, we've got 4, minus 3, plus 12, minus 3, plus 90. So let's see, that's 4, minus 3 is 1, plus 12 is 13, minus 3 is 10, plus 90 is 100, equals 540. And now we're ready to solve. Subtract 100. And we get 22x equals 440. And now if we divide both sides by 22, we get that x is equal to 20. All right, and that solves the problem, right? We might have to plug that back in to find a specific angle, but it didn't ask us to do that, so we'll just box that and call it good. All right, if now we are looking for what the measurement is on a regular polygon for each of the angles, we know how to figure out what the sum is, right? The sum, whether it's regular or not, is going to be n minus 2 times 180. Well, whatever that sum is, all I have to do is divide it by the number of angles, which the number of angles is the same as the number of sides. It's n. So this is our formula for finding an individual angle, interior angle, of a regular polygon. So regular polygons only. All right, so for example, we want to know the measure of each interior angle of the regular pentagon. Now, we've already done some pentagon stuff, right? We know n is equal to 5. 5 minus 2 times 180, that's going to give us 540. So I want to divide that 540 by the number of angles. It's 540 on the inside, so there's 5 angles. How do I split that evenly 5 ways? I divide it by 5, the number of angles, right? So this is 540 over 5, and that is 108 degrees. So each one of these angles, if it's a regular polygon, again, regular is the key word here, meaning it's like an equilateral pentagon, every one of them is going to be 108. Okay, so now this is where it gets a little bit complicated. Now we're going to do one of these problems backwards. So each angle of a regular polygon measures 172.8 degrees. So this is a lot of sides in this because that's just about a straight angle, just about 180 degrees. We want to figure out how many sides does that polygon have. Well, we have a formula for this. N minus 2 times 180 over n is equal to whatever that number is, 172.8, right? So what I need to do now is solve this for n. Now there's multiple ways we can do this. I think anytime I see a fraction, I try to make it not a fraction anymore, right? So I'm going to multiply both sides by n. I'm okay doing that, right? I'm just doing two-sided algebra, so whatever I do, as long as I do it to both sides, I'm okay. That's going to cancel out that n. 1 on top cancels 1 from the bottom. And now I've got n minus 2 times 180 equals 172.8 n. Okay, now I think this is going to be a little bit easier if I take this 180 and I distribute it in. You could divide both sides by 180, but that's going to give you kind of a weird decimal number here, and if we can avoid it, I think that's probably for the best. So 180n minus 2 times 180 is 360 equals 172.8n. All right, we're getting closer. I don't like this 360 being negative. I like it when my variables stay positive. So I could subtract the 180n from both sides, but then I'm going to have a negative over here. Not the end of the world, but if I can avoid it, I try to. So I'm going to add this 360 to both sides. I'm going to move that over here. Not equals, plus 360. And now I'm going to move the 172.8 over. So minus 172.8n. And so that leaves us with what? This would be 7.2n equals 360. Well, it's a decimal, but that's no big deal. We just divide both sides by whatever the number is. It just happens to be a decimal number, 7.2. And now we should get n equals 50. So if a side has an interior angle measurement of this, and it's a regular polygon, that means it has 50 sides.